This is video tutorial number 9 for gravimetric analysis, and this problem would look something like this. A mixture of sodium chloride and iron 3 nitrate has a mass of 0.456 grams. The mixture is dissolved in water and treated with excess sodium hydroxide to form the iron 3 hydroxide precipitate, and the precipitate has a mass of 0.107 grams. And the question asks to find the percent by mass of iron 3 nitrate in the original sample. So in order to do a question like this, we're going to work backwards. And we're going to say, okay, all of the iron in the precipitate came from the iron 3 nitrate. So we're going to first find the moles of iron in the precipitate, then find the moles of iron 3 nitrate that came from the original mixture, convert that number of moles to grams, and then take the grams of iron 3 nitrate over the grams of mixture times 100. So in order to do this, we're going to need our gram formula masses. I already figured those out. Gram formula mass of iron 3 nitrate we'll use at the end, which is 241.88 grams, and the gram formula mass of iron 3 hydroxide, which we'll use at the very beginning, is 106.87 grams. So we're going to start with the 0.107 grams of iron 3 hydroxide. Remember that iron 3 means that the iron has a +3 charge, which is why there's a subscript of a 3 down here. We're going to use dimensional analysis, and we're going to say that 1 mole of iron 3 hydroxide has a mass of 106.87 grams. Notice I'm labeling everything. There's 1 mole of iron for every 1 mole of iron 3 hydroxide. So far what's happening, we went from grams of iron 3 hydroxide, we canceled that out here. Now moles of iron 3 hydroxide cancels out here, and after this step, if we do the calculations, we have moles of iron that were in the original sample. But we actually want the moles of iron 3 nitrate, which for every 1 mole of iron 3 nitrate, there's also happens to be 1 mole of Fe. So really, when we converted here from grams of iron 3 hydroxide to moles of iron 3 hydroxide, that was the same as the moles of iron and the same as the moles of iron 3 nitrate. Okay, so when we do the calculation here, we find out that this original sample had 1.00122 times 10 to the minus 3 moles of iron 3 nitrate. Now, this number does not give us what we're looking for, but I just wanted to, in case anyone was kind of lost in the dimensional analysis, I wanted to kind of start from a fresh point here, because everyone knows how, once you find your moles of a substance, how to get to grams. So if we have this many moles of iron 3 nitrate, all we need to do is multiply by the gram formula mass over 1 mole. And now our mole of iron 3 nitrate cancels, and what we find out is that the original sample had a mass of 0.24217423 grams. Now I'm not rounding here because I'm still multiplying and dividing. That's why I kept this number big out of the calculator and plugged it right back in. I'm going to keep this number big out of the calculator and plug it back in, because we're still doing multiplying and dividing, because now we're going to do, for percent, we're going to do this mass of iron 3 nitrate over the mass of the entire original mixture times 100, and when we get the answer out of the calculator, comes out to 53.1%. So that original mixture was 53.1% iron 3 nitrate, and the other 46.9% was sodium chloride.